Yes, class, am I audible to all of you? Mariam, Abdul, Khadija,
Yes, ma'am.
what about you both, Khadija and Mariam? Yes, Khadija and Mariam, am I
Yes,
audible?
ma'am. Yes, ma'am.
Okay. So, yes, in the last class, we had started with the parallelogram law. So, parallelogram law, I've already told you that this is a very important law. So, R is equal to under root A square plus B square plus 2AB cos theta, where A and B represent the two adjacent sides of parallelogram, right? And they are subtending angle theta between them. So, their magnitude is calculated in this manner, under root A square plus B square plus 2AB cos theta. Then we drop beta with vector A in order to find out the direction. So that is B sine theta divided by A plus B cos theta. This we did. Some questions we have completed. Some questions were left to be discussed. This we did. The three cases we had seen. Now see, this is an important question. That's why I didn't complete it yesterday also, because I wanted a little time in this question. It says that greatest and least resultant of two forces acting at a point are 29 Newton and 5 Newton respectively. Greatest forces which are acting, this means what? Greatest forces means the entire net force is totally increased. See, when I say the net force is greater, the resultant is greatest. If I give you two forces, when can you have the greatest resultant? When you are adding them, then only you'll be having the greatest resultant. So here also, if two vectors are given, 29 Newton and 5 Newton are given to you, it means their greatest resultant will be when you are adding them, and their least resultant will be when you're subtracting them. Now see, F1 plus F2 is equal to 29 Newton. And what's the least value? F1 minus F2 is equal to 5. Let's add them. So 2F1 is equal to 34 Newton. So F1 is equal to 17 Newton. And if F1 is 17, so 17 minus 5 you do, that becomes 12. So F2 is 12 Newton. At least we have this information now. What are the forces? Now what it is saying? It is saying if each force is increased by 3 Newton, if each force is increased by 3 Newton, which forces? The forces which we have found right now, 17 Newton and 12 Newton. Clear till here? Greatest forces, resultant was 29. So we did F1 plus F2 as 29 Newtons. Least resultant forces, that is when you're subtracting them, that is 5 Newton. Fine. We calculated using this equation. We found out the values of F1 and F2. Clear? Now, these were the two lines of the question. Now, the third line is saying that if each force is increased by 3 Newton, if each force, this is increased by 3 Newton. So that means now what is our force? Let's say F1 prime, this becomes F1 plus 3. That is, if this is 17, this becomes plus 3, that is 20 Newton. Coming to F2 prime, that is F2 plus 3. So F2, this is 12. 12 plus 3, this will be 15 Newton. Now, these are the values of forces which you have to include now. 15 Newton and 20 Newton. You have obtained the values of forces as 17 Newton, as 5 Newton, right? Sorry, 17 Newton and 12 Newton. Now the question said that the force is increased by 3 Newton. So once the force is increased by 3 Newton, you have got the values as 20 Newton and 15 Newton. Now it is saying, what it is saying, if each force is increased by 3 Newton, clear till here, we have solved also till here. Find resultant of the two new forces acting at right angle to each other. When two forces act at right angle to each other, what is the formula that we use? Since this becomes 0, we use R is equal to under root A square plus B square. So resultant is equal to under root a square plus b square. What is a? This is 20 square. What is b? That is 15 square under root. So that becomes, this is 400 plus this is 225. This is 625. So resultant, this is finally 25 Newton. This is our complete final answer. Clear? This is the magnitude of resultant. We only had to find out the resultant, no? They are acting at right angle to each other. Further, for the angle part, you can write b sine 90, it would be 90. Directly, I have told you, see, here cos theta will be 0. This becomes b divided by a in this 90 degrees case. So that is 17 divided by 15. Beta is equal to tan inverse 17 divided by 15. So magnitude with the resultant, this is our complete answer. Note it down if any doubts you're having, get it clarified. Look class. After this, see, just remember two terms will be used often. Same order, vectors which are in same order and vectors which are in opposite order. So see, same order means one head is coinciding with the tail of another. Then head, then tail. It's like this is the head, then you have the tail, then head, then tail. If two tails are coinciding or two heads are coinciding, that means they are in opposite order. Why are we studying this? Because we'll be right now studying triangle law, polygon law for that. Now see what is meant by triangle law. See, for triangle law, you need not worry so much. Triangle law, this is very similar to the parallelogram law. Let me tell you this. See, if two vectors are present in the same order, like this, then their resultant, like this, if you see, they are not co-initial, right? They are not co-initial. So what will you see? If they are not co-initial, you will be when they are not co-initial, you will not be able to apply parallelogram, because in the last class only, yesterday only, I have told you that for application of parallelogram law, you have to have the vectors as co-initial. Right now, the vectors are not co-initial. So now how will you solve the vectors? Parallelogram is not applied. See, we take the resultant is taken in the opposite order. Like this. This is the triangle law. Now the angle that we take is this exterior angle of the triangle. And beta that we take is still, this is beta. This is result. Now see what it is saying. If two vectors acting at a point are represented by two sides of triangle taken in the same order, this is very important, taken in the same order, then their resultant can be represented by closing side of triangle taken in opposite order. So closing side of triangle taken in opposite order. See class, this order is opposite. This is this, right? So this is in opposite order, they are in same order. That is exactly what your triangle law says. Now see, formula, magnitude, the direction is same. R is equal to under root a square plus b square plus 2ab cos theta. Tan beta is equal to b sin theta divided by a plus b cos theta. That is exactly the same. It's just that you have to know how to apply it. See, suppose this is a question. A man travels, this says that a man travels 3 meter east, right? Then 4 meter north. Just do one thing, note down further, then I'll discuss this question. Class, written till here, all of you? Shaista, you able to understand?
Yes, ma'am.
Okay. Let us practice one question based on this also. So yes, I was saying a man travels 3 meter due east, then 4 meter north. You have to calculate the displacement. So in displacement, what do we study? We study this, no, that's the shortest path. We join the initial and final points. That's what we have been studying in the first lesson also, right? So when we join the initial and final points, we get a triangle, and now both the vectors, the s1 and the s3, they are representing triangle and they are taken in the same order. So their resultant will be given in the opposite order like this. This is the resultant. This we have to find out because this is the displacement. And what is the angle? When it is traveling upwards north, it means it is making an angle of 90 degree. This is the angle that we take in our formula. See, so R is equal to under root s1 square plus s2 square. That is 4 square plus 3 square. So it's a Pythagorean triplet that will be 5 meters. When we talk about beta also, so very easy question. See, questions are very easy because now you have already learned about parallelogram law. So these are just extensions of parallelogram. Okay, so tan beta will be b divided by a, that is 4 by 3. So beta will be tan inverse 4 by, that's it. Okay, quickly note it down. One more question I want to discuss, which has repeatedly come in the exams, and then we'll start with a new topic, resolution of it. Okay, class. Yes. Now, see if three vectors represent the sides of triangle taken in same order. If suppose this C instead of being given in the opposite direction, this is what I've told you, no, that the resultant this is given in the opposite direction. Instead of being given in the opposite direction, this is given to you in the same direction. Now, how will you solve? So this will directly be zero. Do not waste your time in the calculations. These questions are this is not very important even for you. For your exam, this is not important, but this is a part of your syllabus, so you have to write it and at least have a little knowledge of it. All right. So this will be zero. Coming to polygon law. See, if vectors are represented in magnitude, it's like you are having collections of triangle law. Collections of triangle law you are having. One triangle law, then one triangle law, one triangle law, one triangle law, like this. See, A is one vector, B is one vector, their resultant. This resultant will be somewhat R1, then this resultant with this C. Fine, this resultant with this C. This will be some R2, then this resultant with this D. This would be the final resultant, like this. Polygon law, this will be rarest of the laws that will be used by you. Triangle law will be given somewhere, triangle law will be there, but polygon law is rarely asked in the exams, which I have noticed. It is a part of your syllabus. So if it comes in your exam, you cannot question it up. It's still a part of your syllabus. One last question that I was mentioning you. Yes, if two vectors magnitude A plus B is equal to magnitude of A minus B. When I say magnitude of A plus B, that means A square plus B square plus 2AB cos theta, right? This is the vector. This is how we write the magnitude. No, this is equal to A square plus B square minus 2AB cos theta. This is the vector B, that is A minus B. Magnitude of A plus B is written like this. This is how we calculate the resultant's direction. And magnitude of A minus B is given like this. See, squares will get cancelled. So we will be left with A square plus B square plus 2AB cos theta. This is equal to A square plus B square minus 2AB cos theta. A square, B square will be cancelled. Now 4AB cos theta will be equal to 0. Cos theta will be equal to 0. So theta is 90 degrees. So this is the angle between A and B. This question is very important. It's a very easy question, but it repeats itself. It has been repeating itself a lot. So this is very important question. And if you'll see the reference book also, in every reference book, this question is present. And at the end, you will be able to remember the angle directly by yourself. All right. Complete this, then we'll start with resolution of vectors. Make a note point from here. Now class, this is clear to all of you. Parallelogram law, triangle law, polygon law. Fine. See, the formula is same. Yes, the formula is same in all of them. You have to just apply the same formula for tan beta, for the magnitude and all. Now see, we have to find out if a vector is given at a random angle. In a plane, this is given because we'll be doing motion in a plane. Motion in a plane is a very short lesson. Once you know vectors, you will be able to deal with motion in a plane very well. Now see, resolution of vectors is what? If a vector is given you in a plane, not along x and y axis, we require everything along x and y axis. If something is not given to you along x and y axis, then how will it? So we split up the vector. For example, if this is a vector A, we split it into its one component, that is A1, its second component A2. Fine. So this is what this is. These are the components of it. This one is also the component of it. Means if you add A1 and A2 together, you will get your A back. A1 plus A2. This is how you will get together it back. Now, how to resolve it? How do you resolve it? What are the rectangular components? How do you resolve it? See, this means what is 3 plus 4? It's not just you are adding 3 plus 4. If you are getting a resultant 7, this means 3 plus 4 is 7. This does not mean that we are actually just simply adding it. We have, you can write 7 made up of 3 and 4. So this is the splitting of vectors is known as resolution of vectors. And this is so helpful and this is so important. Such a basic topic for all of you for your class 11th and throughout. Very, very important topic for all of you. See, how do we resolve? This means, suppose some angle is given. Let's say this is 4 Newton, this is 3 Newton. Fine. What is meant by rectangular components? Before this, I just used the term components, resolution of vectors components. What is meant by rectangular components? Rectangular component means this angle has to be 90 degrees. That's why we are calling them as rectangular. This is what is defining the rectangular components. See, if this is given, it can happen this angle is 30 degree, this angle is 60 degree, this angle is 45 degree, this angle is 45 degree. It can be anything. It can be any angle. But sum of both the angles of both the quantities which the main vector is making, this has to be 90, and that is what is meant by rectangular components. And in your syllabus, just rectangular components are present. You need not worry about the rest of the components, just focus on the rectangular components. All right, rectangular components are perpendicular to each other. Now, how to resolve the vectors? What's the process? How will you resolve it? Just remember class 1 thing. The vector with which the angle is being made, that vector is taken as cos theta. Please understand this carefully. Students come in class 12th and they do not know this part also, and it becomes very difficult to tell them in class 12th also, because these are your basics. Understand resolution of vectors. Without this, you will not be able to perform any calculation well. You will be having all the, you will in your laws of motion, you will get a block is present, force is acting like this, calculate something. How will you calculate without resolution? So because everything does not occur along x-axis and y-axis straight away, that you need not resolve. Many things occur in the plane also. That's why we study this lesson as motion in a plane, because this is acting among, this is acting between x and y axis. All right. Suppose this is the main vector A. Angle with which axis with which theta is made, this is taken as cos theta. So this becomes A cos theta. Fine. Now perpendicular to it becomes sine theta. Perpendicular to it, this becomes A sine theta. Now you will be using A sine theta along y-axis. You will be using A cos theta along x-axis. All right. This is how we take it. Suppose the angle is made here. What did we study? Do not remember that on x-axis you take cos theta, on y-axis you take sin theta. Never remember it like this. This will never be helpful. Rule, just remember the rule. Axis with which the angle is made. Angle is made with, the main vector is making angle theta with y. So here you will be having A cos theta this time, and this will be giving you A sine theta this time. This is how we resolve the vectors. First LB class. Till here, any doubts you people are having? Abdul, Khadija, Mariam, Shaista. Because this is very important. One question we'll practice though.
No, ma'am.
Khadija, what about you? You're very passive in today's class. Khadija, please text in the chat column. Abdul, clear to you?
Yes, ma'am.
All right then, note it down. Then a question we'll practice later on. First, next resolution of vectors. See, this is a question given. F1 force, this is acting upwards. No, not upwards, sorry. F1 is acting in XY plane on the right hand side, making an angle of 30 degree with the axis. So this is in plane. Now we have to resolve the vectors. We need the vectors along X and Y axis. So we'll resolve them. Then we have F2 is equal to 5 Newton, right? That is also along X and Y plane only, making an angle of 37 degrees, right? So we have to resolve this also because we need the vectors along X and Y axis. Then we have the third criteria where we have F3 as 2 Newton. This is already along Y axis. So we need not resolve this because this is already present. So see, let's start with F1. If this side, this is making an angle of 30 degree, we'll resolve this will become this angle, this will become cos. This becomes F1 cos 30 degree. That is 10 into cos 30. This is root 3 by 2, which is 5 root 3 Newton. Means 5 root 3 Newton is acting along this direction. Fine. What did we study next? The perpendicular to it one becomes sine theta. So this becomes F1 sine 30 degree, that is 10 into half, which is 5 Newton. So this is 5 Newton. We have resolved F1. This is 5 Newtons over here. This is root 3. This is 5 root 3 Newtons over here. All right. 5 root 3 and 5 Newton. Then, so F1 is resolved. We have both the components. Now the force acting is 5 Newton and 5 root 3. This, both of these are along X and Y axis. So we have completed this. Coming to F2. F2, this is F2 is making 37 degree with the X axis. So this resolution, this will give F2 cos 37 degree, because what we studied, axis with which the angle is made. See, no angle is here. The angle is present over here. So we have F2 cos 37 degree. So this is 5 into cos 37 is 4 by 5. That is 4 Newton. So here we have 4 Newton. And then again perpendicular to it, here we'll have F2 sine 37. This is equal to 5 into 3 by 5. Which is equal to 3. So this is equal to 3 Newton. So one force we have 3 Newton and the other force that we are having, this is 4 Newton. One force we are having as 4 Newton, other force we are having as 3 Newton. And the last one, this is 2 Newton. This is already along the y-axis. So we have all the forces along x and y-axis. Now we have to find out the final answer based upon all the forces which are acting along x-axis and y-axis. What do we have ultimately? We have this. 5 Newton is acting upwards, 3 Newton is acting upwards, 2 Newton is acting downwards. 5 root 3 Newton is acting towards the right, 4 Newton is acting towards the left. Fine. So when we finally get the solution of this will be subtracted from this. That gives you force along x-axis. So 5 root 3 minus 4 will become 5 into 1.732 minus 4. That is around 4.66 Newton. Similarly, this is total what? 8 Newton. This is 2 Newton. So 8 minus 2, because both are acting in opposite direction. So 8 minus 2, this becomes 6 Newton. Now you have forces. See, one force is acting along. See, this is like, wait, let me show you this. Fx is acting here and Fy is acting here. So it means they are making an angle of 90 degree. We have found our Fx, final Fx we have found. We have found our final Y also. Fy and Fx we have found, and they are making an angle of 90 degree. So their magnitude is given like this. All right. And then using tan beta, you will get your final answer. This is how the rest of the part is just parallelogram law. But basically solving this is a part which you have to understand, right? Note this down. Let's take a break of 5 minutes because I have told you that the class duration has increased today. Note this down. I'll scroll it. Then after 5 minutes, we'll then start with rectangular components. One part is left. Then we'll start with dot product and cross product. One more thing, class. Meanwhile, 5 minutes break let's take. While you can write it down also. Send me your date sheets on the group. Date sheets or syllabus, whatever information you have. If you have no information, that it's okay. If you have any information regarding your date sheet and all, please just text me once on WhatsApp in the Learnivio's group which we have created. All right. We'll continue after 5 minutes. Now, C class. After this, under rectangular components only, this was resolution of rectangular components in 2 dimensions. Fine. Now, when we resolve the rectangular components in 3 dimensions, if we talk about 3 dimensions, so see, for 3 dimensions, this is also the least important. When you are revising, you should have the order of your revision on the basis of which topic is most important, which is the least. So this you should revise at the end when you're revising vectors. Rectangular component in 3D means we'll resolve a vector in 3 dimensions because it is present in such a point where x-axis is also present, y-axis is also present, z-axis is also present. So suppose this is A cos alpha. The angle that y-axis is making, this is A cos beta. The angle that z is making is gamma, so A cos gamma. So how do we write the resultant? We write the resultant as, just take their values, A cos alpha, A cos beta, A cos gamma, that is ax square plus ay square plus az square, like this. This is a very rare case that occurs because you usually do not have an object which is present in all the 3 dimensions, whose all the 3 dimensions are changed. Usually we have 2 dimensions. That's what we have studied. It is the prime most important thing which you have to remember. Now, then we have talked about the normal one, rectangular ones. Yes, the normal vectors we have talked about, and we have talked about the rectangular ones. Among the rectangular 3D, this is rectangular component in 3D. Here you have all the vectors present, but that's what I'm saying, the values aren't changing. Values are fixed, and see, the values are changing. All the values that we put, this is not constant, this is not something that is fixed. Angles can be anything, it's just a representation. Alpha, beta, gamma, this means a representation. Clear? Okay. Now see, cos alpha is ax by a, cos beta is ay by a, cos gamma is az by a. This is standardized. This you don't need to do the derivation, just remember this. See, when we put the values of cos from here, how have we got the values of cos? Ax is equal to a cos alpha, so cos will be ax by a. Ay is equal to a cos beta, so cos beta will be ay by a. Az is equal to a cos gamma, so cos gamma will be az by a, like this. So we have all the values of cos. Now we are squaring and adding them up. This is the values that we'll get. So when you are squaring and adding it up, this is equal to ax square plus ay square plus az square divided by a square, right? See, what was a? A is under root ax square plus ay square plus az square. If I square both the terms, if I square this also and if I square this also, this will become a square and here the root will be gone, right? See, if I square this, under root a is ax square plus ay square plus az square. If I square both the terms, this will become a square and this is going to be ax square plus ay square plus az square. Now this term I can write this as a, right? That becomes a square divided by a square, that is equal to 1. What is the conclusion? Conclusion is that cos square alpha plus cos square beta plus cos square gamma is equal to 1. Some questions I have found, very previous questions, where to prove this is asked. Fine, just to prove this. Basic questions are also there. Do one thing, note it down, then one question I'll show you based upon this, how the questions from this will come. This question we'll practice for direction for science. Or let's do one thing, let's practice the question simultaneously so that this will be clear. See, this is, suppose this is given to you. Fine, 2i minus 3j cap minus 4k cap. Yes. Now we have to first find out the magnitude of vector A and direction cosines. This is one question that is sufficient. See, magnitude of A. What have I told you? Whenever we have to find out the magnitudes, coefficient square plus coefficient square plus coefficients square, like this. Square of coefficient of I cap, square of coefficient of J cap, square of coefficient of K cap. So this is 16, 4, 20, 20 plus 9, 29. So that becomes root 29. This is the value. Now direction cosines. How do you write the direction cosine? See, this is the first part, second part. Cos alpha is written as AX by magnitude of A. AX, what is the coefficient of I cap? 2. So this becomes 2 by root 29. Then we come to cos beta, that is AY divided by A. AY was minus 3. Yes, this is minus 3. Coefficient of J cap, that becomes minus 3 by root 29. Cos gamma, this is AZ by A. This was 4 K cap. 4 by 9. That's it. This is how you have to solve the vectors. Fine, just this. This, remember, if it is asked not to prove, this can be asked to prove. Because in some question papers, this has been asked. This proof is a part of your syllabus though, but this topic is least important among the rest of the topic. The topic that was most important was the resolution of vectors in 2 dimensions. Note down this 3-dimension one also, this 3-dimension one. See class, now this completes with resolution of vectors. So parallelogram law, triangle law, polygon law, resolution of vectors, these are very important. Now the next two important things are, that is actually one heading, but we'll be doing it among two headings, dot product and cross product. These two are left. Then vectors will be over. We'll be practicing the questions of projectile motion. Projectile motion will not take a lot of time because lots of portions have been deleted also in your from your syllabus. Now see, when we multiply vectors, this is basically all about vectors multiplication. When to use dot product, when to use cross product. If you have dot product, how will you find out the answer? If you have cross product, how will you find out the answers? See, when a vector is multiplied with just a number, it can be positive answer, it can be a negative answer. This means, for example, I am having some value of any vector. Let's take velocity. This is 3 meter per second. One number, n is just a number. I have multiplied 3 with 3, that gives me 9 meter per second. I have multiplied 3 into -3, that gives me -9 meter per second. So when a vector is multiplied with any number, that gives, it can be positive, it can be negative depending upon the number, one thing. Secondly, this was a number, vector multiplied to a number. If vector quantity is multiplied with a scalar, like there is one formula of power. Okay, this I'll tell you, vector with vector, or let's take vector with scalar, where or let's take the formula of vector that is multiplied to a scalar number. Let's take a random example. See, suppose, though examples are written down, I'll discuss them in detail, but just for the brush up, suppose a vector is given. Let's say, again, let's talk about velocity. This is 3 meter per second. Fine. Magnitude will become n times. N is your scalar here. Whatever is the given, and whatever is the value given, n is scalar. So vector will become n times. That means it will get multiplied. Now, this is also easy. These are just basic multiplications. Here also you are getting it multiplied to n times. In this case also you are getting it multiplied to n times. Easy. You have to do nothing. You just have to multiply the two quantities. Whatever it was, it will remain as it is with just a multiplication. But when we multiply vector with vector, here comes the issue. When we multiply a vector quantity with a vector, you cannot directly make it n times. You have two conditions, dot product and cross product. Dot product means the final answer is a scalar answer. Cross product means the final answer is also a vector answer. Dot product, when do we use? When vector is multiplied with vector gives you a scalar quantity. Fine. Cross product, in cross product, when vector multiplied to vector gives you a vector quantity. Fine. So this is just an overview of when you have to mainly focus on vector multiplication to vector. This is what is meant by dot product, this is what is meant by cross product. Now we have to discuss dot product and cross product in detail. All right, because and we'll be just discussing some things over here. Then as soon as the chapters will be passing by, the portions will be included within them. Like this, I was telling, unit remains the same, unit will be the same, like this. Number is 3. So finally, f multiplied to n, that gives you 3 into 2 I cap. That makes it 6 I cap Newton. Or f is equal to ma, mass is 2, acceleration is 2 I cap, that makes it 4 I cap Newton. So this is how we write it. Note this down. Note this, make this in the form of table, or you can make it as separate paragraphs also.